All right, folks. So I'm trying a little bit of a different setup with my internet. I'm plugged directly into Ethernet. Um, trying a couple things out here. So I know there's been some problems with the stream fidelity lately. The signal coming through clearly, and my voice and the material being audible and um, what's the word I'm looking for? Comprehensible. Because the streaming quality has been bad. So hopefully these changes are going to be useful and are going to result in a cleaner, more intelligible stream. Um, if you're hearing this and you're on the basic prep Slack thread, just if somebody could confirm that I'm coming through clearly, if it's breaking up a little or if it's breaking up a lot, um, that would be useful. So go over there and just let me know if it's working out okay. Mm. Excuse me. So that's where the delay was getting started today, is just getting that all kind of set up and the details with that. Cool. Oops. Let me just do this. Okay. So let me get set up here. Okay. Awesome. Thanks for letting me know. Okay, so sanity check. Where this is, I'm just doing this. This is a sanity check. You just check your environment, make sure you're actually going to get output when you run your code. That's always nice to know. That way, if you're not getting it, you know you're not going insane. All right. Cool. So let's see, where were we left off last time? So just a quick update on this. Study halls are oriented around us taking questions and being able to go off of people's questions. So if you have questions, if you're working through Learn, go ahead and paste those questions in the basic in the thread in under the message in basic prep. I see a couple of you in there. When you paste your question, paste in the link to the question in Learn, as well as any code that you have in a formatted cell block if you can. If you can't get it formatted correctly, just paste it in, and I will make a note on how to do formatting inline in Slack to help you out with that. So we're absolutely open to taking questions. That's fine. I think some people have not wanted to intrude, and that in reality that's what study hall is about, is taking your questions so we can work through them together in study hall. Secondarily, I'm going to go through the material in Learn and just talk about, just kind of teach from this, use this as a curriculum to just teach from, and I'll go through and solve the problems as they come up, and we'll go from there. Cool. So I think we left off, last time we left off on list basics. And I will take requests if somebody has some material that they want me to go through, one of these sections, I can do that as well, of course, at my discretion. So cool. So we're just gonna start off with going through list basics a little bit, and we'll go from there. Great. So I'm trying to do a recap for everyone, but the last one was on Friday, and it's been kind of a long weekend. So let's see. I think last time, I'll just do a recap of list basics. So let's talk about real quickly what a list is, how to make one, and just sort of basic manipulation. Excuse me. So a list is a collection of objects whose type is arbitrary, right? So it's a collection of data types, or data, right? And the types are arbitrary. The types don't need to all be the same, and it can be anything that we think of as a data type. So it can be ints, floats, strings. Let's do bool. None. It can be other lists. Okay, this autocomplete is driving me crazy. I keep forgetting to turn this off. I think it's way down here. Excuse me. I have it turned off on my other computer, and I keep forgetting to turn it off on this one. Let me just see if I can find it really quick. Oh, I know. It's in packages. Okay. I'll just re-enable that. Oh, is it this one? Yay! Okay. Thank you. Sorry for the delay there. I just had to I had to get that autocomplete thing stopping. It was just driving me nuts. Okay, so we were talking about lists. What kind of data types can they hold? These are some of the types it can hold, as well as other lists. Okay, so we can hold any type of data in there. So we can declare a list using square brackets, and we can say, let's put an int, and then a float, and then another float, and then a bool, and then a string, so we can just have whatever kind of items we want in the list, right? We can declare a list and set it into a variable, or point a variable identifier at it. We can say x, actually do list equals empty list, just square brackets like this. And we can add to the list using append. So if I print list here, obviously there's not going to be anything in it. And again, append to the list. I can add something into the list with list.append hello, and that will add hello into the list. So if we do print list again, our list will have that element. Cool. So basic, real quick overview with lists. And we'll go more in depth into those. So we do have a question in Slack that I'm going to take. Oops. If I can find where, oh, okay. If I can find, okay, here it is. Yeah, okay. I got a couple people on this, saying they're on this one. Let's do this. Oh, the enumerate function. Yes, the wonders of enumerate. Okay. So this is a little bit of a funny one. So I would say enumerate. We need a little bit of test data here. Let me see if I can actually find this. We talked a little bit about strings yesterday, or Saturday, excuse me. And so I'm going to include a little bit of string work in here because we didn't get all the way through that material as well. So I just want to get a list of all the words from this string so I can just have something to work with. So as we go through the other stuff. So right now I have this variable called text, which is equal to this little bit of text. This is just a little Robert Frost poem. You've probably heard it before. And I just use this as a sort of a general sort of text processing template, as opposed to like lorem ipsum or something, because it has some repeated words and it has some repetition as well as some variety, and it's not too huge. So we can actually work with it. And it has some capital letters and some punctuation. So there's enough variety going on that I can just gives you a little something to work with when you're doing text processing stuff. So, but let's look at how we can take a string and turn this into a list. So we have our string called text. Excuse me, text. And if I print that out, it's just going to print out that poem. No surprises there. Eventually it will. Anyways, okay. I want a list of all the words, so there's a handy built-in method for strings. So this is a string method, meaning we can call it on a string like this. We can say text, which is a string, dot split, S-P-L-I-T. It's a really important method for strings to know. Let's run that. And what split is going to do, it does not change the string. So if I print text again, I'm going to have that original text that I had. So it doesn't alter the string, but it just returns, like a regular function, it returns the it returns a list where the string, where each item is separated in the list by the space character, right? If I don't pass anything to split, it's going to separate the items based on spaces, new lines, and tab characters, which are all the white space characters. So essentially what that means is if I call it on a body of text, it's going to give me individual words in that list. Okay, cool. So now we have a little bit of data to work with. So I'll call this text list. I feel like calling this, yeah, we'll do that. Okay, oops. Text list equals text.split, and that'll be the text list. All right, so let's say I want to go through this list in a for loop. I'll say for word in text list. Oops, text list. We'll just print word. Okay. And I'm actually just going to do this real quick. There's another string method that I'm going to do, which is dot lower. And that's going to change all the uppercase characters into lowercase characters. Or change is kind of confusing. It's going to return the string where all the uppercase characters are lowercase, the lowercase versions of themselves. Okay, and that'll get rid of the capitals, and that'll just help with different comparisons and make the data a little more consistent. All right, so so let's say for whatever reason that now I have this list of words, and let's say for whatever reason I not only want to represent the word in the for loop, which I'm doing here just fine, but I also want to represent the index. I also want the index that's associated with each of these elements in the list, right? In this case, it's words, but I mean, this could be a list of numbers or a list of Boolean values or whatever. So in this case, I want to, for whatever reason, I want to also have a representation of the indices alongside the elements, which are words. So go ahead and share your thoughts on this in Slack once you hear this. How might you do that? Think about this, and you can put it in Slack when you get a second. So think about how you would do this. You could, there's a number of, there are really two ways to approach this. One way that might seem sensible, you might say text list dot index of the word, right? And let's print that out. And we'll print word next to it. Oops, here, let's do this. So this is this is just to show you this is actually not going to work for that purpose, right? This won't actually give us an accurate index. It does something interesting. It's valid code. But if we look at this, whose is 0, woods is 1, 2, 3, 4, 5, and then back to 4, right? So the second I, since it appears in here a second time, we don't get the next index of I. We get the index of the first occurrence of that element, right? In there, right? So, so this might be a way to think about this, but it's I just bring this up because I've seen people do this before, try to use .index to get the index, and it doesn't quite behave like you want it to. Another way to do it is to go through a range. And a range takes a number and it goes from 0 up until that number, but it excludes that number, right? So the length of a list, if I have 5 elements in a list, the indices are 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4, right? So the length, though, is 5. So if I pass the length of a 5-element list, if I get the len of the list, I'm going to get 5, and if I pass that len, which is an integer, into range, it's going to be in range 5, which is going to give me 0, 1, 2, 3, and 4, which are the indices of the list. So we can do this, we can combine len and range in this way. We can pass the length into range. And that will give us the appropriate index, but notice in our for loop, we lost the word. We don't have the word. That's not a huge deal because we can actually use the index to recover the word. So right here I can say word equals text list sub I, right? And that will print I, which is our index, and word, which is our word. That'll give us, this is a working solution. I promise I'm getting to enumerate. We're building our way there. I know I've gone on two sort of things with split and with this range thing. Okay, so let's look at this and let's see if we have that same problem with I. We could look at any I, but we'll just look at the same spot. So whose is 0, 1 is woods, these is 2, 3, 4. 4 is I, 5 is think, and 6 is I as well. So this index for I is not repeated like it was when using the dot index method. So this works. This will give me a representation of the word and the index in this way. But the only problem is it's not quite elegant enough for a truly Pythonic solution. And this is one of the things I like about Python is there's just such an emphasis on like not only code that works, but code that actually looks nice and is easy to deal with. So there's a better way. We can use the enumerate function. And all we have to do is say enumerate text list. Now this changes our for loop a little bit, changes the way that we can write our for loop. So I'm going to call this pair to show you what this is. So instead of giving me back a single element, it gives me back a pair of elements, right? Right? And you can probably guess what those elements are going to be. It's going to be the index followed by the element, which is the word in this case. Notice that they're surrounded in parentheses. Let's look at this a little bit. Oops. We haven't talked about tuples too much yet. But if I get the type of this pair, we're going to get class tuple. Now, a tuple is a lot like a list in that it's an ordered collection of arbitrary elements. The difference is that in memory, your list literally contains the values in the list, whereas a tuple contains only pointers to objects in memory, right? So it doesn't actually contain the elements, it contains pointers to the elements, right? In practice, what that means is that lists are sort of a complex type. You know, they need to be capable of changing, and they need to be capable of being aware of the types within them changing, if those types are capable of changing. Tuples are a simpler type in that they just hold pointers to different objects in your program's memory. And the pointers just need to know where to point. So they're just pointers. And they point at whatever objects they point at, and those objects can change and do whatever as they need. What this means is that lists are immutable. Lists are mutable. They can change and fluctuate. They're a complicated type, whereas tuples are a simpler type and they're immutable. But in practice, they function very similarly, right? So you can, there isn't an append method, but you can concatenate like you would with a string. You can concatenate two tuples together to add things into a tuple or get different transformed versions of that tuple. And you can also index into a tuple, and you can use indexing and slicing. I'm blocking on the term. You can index and slice a tuple just like you can a list or a string. So let's look at this pair, and we can say pair sub 0 is going to be our index, and pair sub 1 is going to be our word. Actually, let me do it like this. Cool. Okay, so now we have access pretty directly to each one. So we could do something like idx, comma, word equals and I'll just print idx word. Okay. So this is a little bit funny looking syntax here, right? So what's happening here? some of you may recall that we covered something that looks similar in like real early on in the Learn material. I actually remember going through this in stream, and I glossed over this quickly, very purposefully, because I didn't want to spend a whole lot of time on it. I didn't want people to get confused, like about too many different ways of like declaring variables. But at this stage in the material, I think it's appropriate to take a second look at this. This is a valid way of declaring two variables at one time. So let's look at what's happening here. So on the right-hand side, I have comma-separated elements. Now, it doesn't have parentheses around it, but when you have comma-separated elements like this, you might think, well, that's a pattern that's similar to a list, except it's not in brackets and it's not in parentheses like it would be if it was a tuple, right? But since I'm not explicitly saying what type this is, but there's a comma separating these, Python is just going to assume that this is a tuple. And you can declare a tuple like this, right? And this will also work for lists. Whether this is a tuple or a list, I can pull it apart with I can like pull it apart into its individual pieces into variables like this. Okay, so this is important to remember. Whenever you see a tuple, you can deconstruct it or unbox it. This is sometimes called unboxing or deconstructing a tuple. You can unbox it into its elements like this, right? So this is going to give me access to each of those elements individually, right? Now, I made a tuple by indexing into each one of these items in a tuple, right? So I can actually I don't need to do pair sub 1 and pair sub 0. I can just say pair, P-A-I-R, right? Pair is a valid tuple on its own, and I can just pull it apart into its elements. I can unbox it into IDX and Word just like this. We'll run it, and we'll see this is going to work just fine. Okay, so there's one final step here. I said this a moment ago. Anywhere in your code where you find a tuple, you can unbox it, including in your for loop directly, right? So I don't need to call that pair. I can just call it IDX and Word. And I can do that right in the for loop. So enumerate gives us the ability to access the word or the index of an ordered collection, as well as the element at that index, just right off the bat, right? So I don't have to do an extra step. I just know, like, when I have a problem that says where I think, okay, I need to be able to access the index of this element and the element itself, I can just use enumerate right off the bat, and this is just easy, straightforward code to be able to write. For the people who were asking about this, let me know if this explanation makes sense or if you have follow-up questions. I'm going to just go through the rest of this lesson. So the goal of this lesson is to be able to write a for loop that can keep track of both indices and I'm going to say elements in the list. Use the enumerate function to write more complex for loops. More complex and nuanced for loops. So sometimes you'll need to loop through the items in a list and keep track of the index of each item. The enumerate function iterates through the item and the variable counter. Okay. That corresponds to the item. Okay. So this did remind me. Sometimes you want to have like different level of, sometimes you want to control where the index starts here. And I'm going to shorten this list. Let's get the first 10 elements. So we'll say I want to go to 10. Give me 1 second, folks. I got somebody knocking on my door. All right, sorry about that, folks. My housemate is leaving, and her dog gets nervous, gets real bad separation anxiety, so they just leave her with me when they when they leave the house, so that the dog doesn't get nervous. So I have a streaming companion now. This is Pokey, and she's a good dog. Anyways, cool. I will try to not let her be a distraction. All right, back to it. So let's look at the output from this. So I'm limiting this text list just to a few elements, just so we have something kind of more bite-sized to work with. And just to show, here, let me actually scroll this up. Just to show if we wanted to adjust the index, like we could do that as well. So if I wanted to start the index at, let's say, 1, let's see how that's going to affect our code. Now, again, this is a good place to check your assumption. Like every time you're going to run a new bit of code, think like, and you have this notion like, oh, I don't know what's going to happen. That's fine. Just think, okay, what might happen? What might my assumptions be? And probably those assumptions are going to be wrong. That's fine. But I just think it's important to kind of notice that you make assumptions and just make a habit of like kind of understanding those assumptions versus understanding the assumptions that the language developers of Python made. Okay. So let's look at the original output where we didn't say what index number to start on. We have 0 as whose, 1 as woulds. Let's see what changed here. So we have 1 as whose and 2 as woulds. And instead of ending at 9 with house, we end with 10 as associated with house, right? So sometimes you want to adjust that index, and you can do that right in line with enumerate as well. You could, of course, do something like equals idx plus 1 or something like that. Of course, we could turn that into idx plus equals 1 as well, and that'd be the same thing. And then it'll get reset above. So we could do it that way, but in the interest of Pythonic elegance, we have a way to just keep that all on one line, and now we have this nice clean for loop. Cool. All right, so we're looking at this code. Oops. Yeah, and somebody, for the people who are asking this question, again, please do let me know if that's actually, if the way I'm answering this is working for you, or if you're left still wondering how this is working. So. Or, I mean, I guess, like if you have any lingering questions, like feel free to pop them in there, is what I'm saying. Cool. So what gets printed? Here we have a list, right? We have our elements 6, 8, 9, 1, 2, 5. And for IDX and num in enumerate list, I used words instead of numbers, but same diff, right? Then we have on the left it's 0, 1, 2, 3, 4, 5, and on the right it's the elements 6, 8, 9, 1, 2, 5. So when using enumerate, make sure to create two variables or two identifiers in your for loop. So idx and num. The first one is always going to be the index, and the second one is always going to be the number. Here they're demonstrating the same thing that I just showed, where you can start the index, but they're starting the index at -62, which is interesting, right? So -62, then we start at -62, then we get -61, -60, -59, -58, -57, etc. Cool. Assign the variable second half. In the above example, idx stores the index and num stores the current element of the list. The enumerate function actually takes a second. Yeah, that's okay. That's what I just said. All right. Sorry about that. What is the proper way to declare a for loop using the enumerate function on a list called list? Since it can be done with or without a start parameter. All right. So for idx and val in enumerate 1 and list, proper way to start a for loop called list. Okay. So we know it's not this one because the first argument to enumerate is always the collection. Always has to be that it's the thing we want to enumerate, right? So it can't be this first one because the first argument being passed here in this example is a number, right? So we don't know what's going on there. For val in enumerate length of the list, so len returns an integer, and again, when enumerate only takes one argument, that argument has to be a collection. So this is an invalid. I think we would get. Let's just see what's going to happen here. Oh no, my code's gonna produce an error. I'm a terrible programmer. I'm making fun with you guys, just so you know. Oh no, it crashed. No, see, I'm just making a show of it because every time you're like looking at, I mean, here's a totally valid way of going through these is to run each one of them. You know, like I would not consider that cheating. I would consider that good practice. You know, that's what I do when I'm looking at code that I don't understand. I run it until I understand it. Like I just beat up my terminal with broken code until I can produce code that does what I want it to do. So, yeah, it's always good to just check stuff out. But let's actually see. So we ran it with len instead of len of the list instead of the actual list itself. And this gives us a type error. It says int object is not iterable. So we cannot iterate over an int object, which might be counterintuitive. You might think, well, you know, and maybe an int object, maybe your assumption is that, well, an int object should allow you to iterate that many times, right? That's fair. That's a fair assumption, and that's certainly useful behavior. That's just not the assumption that is made when Python sees an integer where it's expecting an iterable type. It just doesn't regard integers as iterable. If you have an integer and you want to turn it into something iterable, which len is our integer, we can give it a range. So that's how we can recuperate that behavior. I mean, that's potentially useful behavior. But this is the way we can convert an integer into an iterable type, right? I said I wouldn't get off on tangents, and look at me go. Okay, there we go. There's a result of that. Cool. Oh, it's going to give me an error again. Same error. Int object not iterable. Boom. Okay. Let's do that. Okay, let's look at this third one. So for IDX val enumerate range of the list. Pretty sure I just tried that. So this is actually valid code. Excuse me. This is actually valid code, right? Range is, oh, excuse me. This is not valid code. Think about why that's not valid code. For IDX and val in enumerate range list, right? So range, this is sort of the opposite thing, right? Range has to take an integer. List is a iterable, it's a list, it's not an integer. So we can't do, let's see what error this gives us. Know thy errors. Okay. Bogey, no. Chill out. Relax. Okay. So this says type error, list object cannot be interpreted as an integer, right? So Python doesn't know, like, we're not asking it to do anything special with this. It's just, it doesn't know how to convert this to an integer. So same thing, if we wanted an integer, we probably want the len of this, but I already ran some similar looking code, so I'm not gonna, we won't explore that too much. Cool. So we know it can't be that one. Then, I mean, by the process of elimination, it has to be this one. But let's just look at this. For IDX, val, so IDX is the first one, that's good. Value is whatever the element is, that's fine. And then enumerate, and then we have collection, which is list, and then one, which would be the index, so that'll be that one. Cool. All right, what does this code do? What'll it print on the last iteration of the loop? IDX over num. So that'll be what? What'll that be? 99 over 100? I don't know. I don't want to think about it. I am lazy. But thankfully, my Python interpreter is eager to help, so I'll say 99. Boom. All right, one more. Enumerate function. Write a function called alt series. Let's do this. Write a function called alt series. This function should have one parameter, which will be a list of numbers. This function should, okay, so the parameter will be a numbers list. So let's do list equals, I'll just do this, ls. List equals, okay. Cool. So it'll take in ls. Good. Def alt series takes in num list and returns. Oh, what am I doing? Why don't I copy this? Okay. Oh, see, it already gives me some tests here. I'm just going to do these. Perfect. We'll just comment those out. Print that out. Ourselves a little space here so we can see what's going on. Good. All right, so we've got 3 tests here. I'll keep my original one around. Cool. Oh, I don't need that again. Okay. Write a function called alt series. Function should have one parameter, which will be a list of numbers. This function should, okay, it should do whatever this says. In a variable called alt sum. Let's make that to 0. That's probably where we're going to start it since it's a sum. Sum together all the numbers. Sum together all the numbers in numList, where the values with even indices are added, and okay, values with even indices are added, values with odd indices are subtracted. In a variable called powsum, do this. Looks like there's another one there. Okay. In a variable called powsum, looks like we've got powsum and idxsum. We'll do these too. Oops. We'll probably just start those at 0 for now. In powsum, we want to sum together the results of raising each value to the power of the index. In idxsum, we want to sum together the results of raising each index to the power of the value at that index. So, okay. The function should return these 3 variables in the order altsum, powsum, idxsum. Well, that's convenient. That's just the code that I want to return. Good. Okay, so let's run it. We have a basic template up. We have our sort of intended outputs, and we're outputting them. So this is complete in the sense that it's end to end, right? It it has all the elements that it needs to be complete, but we don't have the process in place yet. There's a good place to start the function. So let's just go check these off one by one. We'll do alt sum, then we'll do powsum, then we'll do idxsum. So oops. Oops. Pokey. Chill out. She's bothering me for attention. Okay, I gotta type. I swear to God. Okay. Excuse me. So let's do. So I know since I need the access to the element and the index, I'm gonna say for. Oh no, I'm typing. I'm still typing Pokey. IDX. I have to type one-handed. This dog. For IDX and num in enumerate. In enumerate num. Here, we'll do this. Pokey, God, stop it. Okay, in enumerate num list. Then we'll say, now we need to see if, I just noticed something. Okay, the summation index should start at 1. So we have to start our index at 1. So we'll say 1. And we want to know if that index is, if IDX, we want to know if the index is even, because remember for alt sum, sum together all the numbers in num list where the values with even indices are added and odd indices are subtracted. So we need to know if the index is even or odd. So think about how we would do that. We can say if index mod 2, because if something's divisible by 2, we know that it's even. If it's divisible by, if it's not divisible by 2, we know it's odd. That's the definition of even and odd, right? So if IDX mod 2 equals 0, we know it's even. Else IDX is odd. Oops. I had to make that a comment. So we'll just do this. IDX is even. And we'll put a pass in here as well. Okay. Cool. So if it's even, we want to add it. If it's odd, we want to subtract it. So we'll say alt sum plus equals num. And then down here, we'll just say minus equals num. Easy. Nice. Let's see what we get. So for our 3 results here, I don't know what I'm expecting for this first one because I didn't crunch all the numbers in my head and I'm too lazy to do that. So, oh, I put an I here instead of 1. I meant to put 1 there. You can see it says name I is not defined, and I just looked for an I in my code, and that's what I found. So we get -5, 4, and then 0. 4 and 0 is what we're expecting for the last 2, so that's fine. That's great. Cool. Moving on. So that looks like alt sum is sorted. You know what? I actually want to, I'm going to get rid of these comments. They are not necessary. And we're going to just put these on one line. Often when you have simple conditions like this where there's only one line inside, you can always just put them on one line. You don't need to actually put them on the next line and tab them in. If there's only one side in the condition anyways, you can just do this. And it just makes things a little cleaner, I think. Or I like it. So pow sum, so that'll be pow sum plus equals IDX to the num. No, it's the other way around. Num to the IDX. And IDX sum is IDX to the num. Okay. Said we'd go one at a time, but I took that 2 at a time. We'll just see what we get. So I'm expecting the first one to be 4, 4, 3, 3, 0. Yeah, 6, 6, 2, 8, 2. This one I get 4, 4, 3, 3, 0, 6, 6, 2, 8, 2, and then the next one I'm expecting 0, 4, 10, and that's what I get there. Good. So this all looks good. Boom. Lovely. All right, cool. All right. We got another question here from the stats section. Let me look through this. Or we're looking at mode. This is in stats. We'll just take a quick look at this. Not sure I want to go too deeply into stats right now. So this is mode challenge 3. This challenge. I think this is mode challenge 3 if I'm not. Is that what you said? Yes. Mode challenge 3. Okay. I'm sorry. Maybe I'm being dense here, but I'm not. I'm not able to like glean what your question is from what you sent me compared to what I'm seeing here. But let me. Yeah. Um, I think I want to let's just handle this offline after uh, class, if that's all right. Apologies for that. I'm going to move on to the next question. Okay, so we got a problem or a question on open-ended problems. Oops. Open-ended problems number 3. Twin prime. Okay. Complete the function to the following specifications. This is an interesting one. Okay, so the twin prime conjecture is the theory in which there are an infinite number of pairs of prime numbers that differ only by 2. The function to write here finds the nth twin prime pair. For example, the 5th twin prime pair is 29 and 31. Okay. Okay. So the parameter is nth and it returns a list. Seems like it should return a tuple, but whatever. I'm going to write mine to return a tuple. Return, we'll do P1, P2. We'll just do that for now. Actually, no. I'm not going to do that for now. Before I start solving this, yeah, okay, so I just saw a comment come in. Previously we created the next prime function that could be useful here. Yeah, exactly. That's what I was going to say. So before I start this, I actually want to write some helper functions to help me with this. So I'm thinking I want to do an isPrime function. Takes in n and returns true or false. And I want to do isPrime will return true or false based whether or not the number is prime or not. So, and then I want to do a next prime. So it'll take in n and it'll give me the next prime number after n. And I think just for the sake of, just because I want to write some more code, honestly, it's just because I want to write some more code. I'm going to write isPrime based on factors list. So we'll do def factors list takes in n. So this is going to return a list of factors. So we'll return. Oh, come on. We'll say list of factors equals an empty list. Good. And we'll say for num in range, we'll start at 1 because we can't divide by, here, let's do this. For divisor in range 1 to n, including n, we'll just include n. We'll say if divisor, if n mod divisor, right? So mod, it's easy to think about it as not division, but it is division. The reason we want to start at 1 is because we can't divide by 0. We can't have a 0 in the lower term of a division. So if n mod divisor equals 0, we know divisor is a factor of n. So we'll say list of factors dot append divisor. So yeah, and then we'll say factors list in. So with isPrime, we can just say return factors list in less than or equal to 2. And we need to handle an edge case here. We need to say if n is less than or equal to 1, return false. Oh, really? Yeah, okay. Good. So we'll return false. That's our edge case. And then we'll do that. So let's just test isPrime real quick. Oops, I'm doing this out of order. Excuse me. I, and we'll get I from our for loop for I in range 20. We'll do that. Okay. If n mod divisor equals 0. There we go. For some reason I forgot to put that 0 in there. Less than or equal not supported between list and int, which is, oh right, if the length, that's what I'm looking for here, right? Len See, this is actually, I'm glad I got these errors. I don't worry about, like, this should show you the kind of skill that you want to develop. I get a lot of people saying like, well, my code still gets errors. Like I still get errors sometimes, so I don't think I'm ready to like. It's sort of this attitude like, well, I'm not a real programmer because sometimes I still get errors. I mean, they pay me to teach people programming, so I mean, I ought to know at least a thing or two, right? You know, and I still get errors all the time. So the skill that you're trying to develop when you're learning coding is not to always avoid getting errors. Excuse me, I'm trying to turn my light on here. It's to learn how to read your errors and handle errors. And the way you learn how to handle and read and process errors is by getting lots of errors. So every time you get an error, think, okay, this is the action of learning programming. This is literally the act of like, this is the central skill that I need to develop, is learning how to deal with errors as they come up, because they come up constantly in development. If you get all the errors in development, then you know, like, hopefully you've run your code through the ringer enough in development before deployment, and you know, it can be more robust that way. So if you're experiencing the it should be a term for that, like error fear, then don't worry about it. It's normal. You're never gonna stop getting errors. Well, I don't know, unless you're one of those extraordinary people that can just do that. So, all right. So let's just look at these numbers and see if they're prime. All right. I know it can be long-winded. Thanks for putting up with me. Cool. So 1 is not a prime number. 2 and 3 are prime numbers. 4 is not. 5 is. 6 is not. 7 is. 8 and 9 are not. 10 is not. 11 is. 12 is not. 13 is a prime number. 14, 15, and 16 all have factors. 17 is a prime. 19 is a prime. Good. Okay. I think this is working fine. I've been known to be wrong before. So if you see an error, do let me know. Cool. Otherwise, it looks like is prime is working just fine. Okay, so let's do next prime. So next prime itself is an open-ended problem, and I think this was brought to, yeah, next prime right here, right? So this one was actually the previous problem. So we're gonna knock both of these out with this one question. So let's do next prime. So we'll say while, I'm just gonna do true. I always have a hard time thinking about like what the exit condition is in a while loop. It usually occurs to me as I'm like midway through the loop, through the logic. So I just lock it into the on position with while true. Usually that's what I do. So while true, we'll say if is prime, right? Okay. If is prime, I. Yeah, we'll do that. So I'm going to make oh, you know what? I'm going to just use n. I'm going to use n directly. I'm going to say n plus equals 1. And we'll say if is prime n. And notice, since, like, imagine we're starting with a prime number. So imagine we're starting with 11. 13 is our next prime. So that's actually a twin prime. So, or let's do this one. So imagine I'm starting with 13, the next one should be 17. So I don't want to check 13 again. So if n is 13, I say while true, n plus equals 1. So n is now 14. And then I say if is prime 14, then we can return n, right? Next prime returns the next, right? Okay. So that should do. Let's do this. Eh. Oh, is prime is not defined. Fine, I guess it wants me to write all the code. Ah. Yay. Okay, cool. So notice this is an open-ended problem as well, right? Because we don't know how many iterations. I mean, if we knew, then we would have like an algorithm for predicting prime numbers. That wasn't this. That wasn't this. Just this brute force approach, or I mean a formula, not an algorithm. I think that's what I mean. Okay, cool. So this is their solution. Mine is clearly way cooler. So yeah. Okay. Anyways. So that's next prime. So we got factors list. We got is prime. We got next prime. Okay. Now I want to do twin prime. This is a tricky one. So I'm just going to do while true again. I think that'll be fine. And then we'll say so what do they take in? Nth. I think I'll do this. Oh, okay. So what I'm gonna do is I'm gonna make a twin prime list equals an empty list, and every time I find a twin prime, we're gonna pop it in there. And then what I want to do here, so now I know my exit condition. I can say while len twin prime list is less than or equal to nth. I might need to change that to just less than. I'm not sure. I'm not going to think about it now. We'll figure it out if I get the wrong answer. We'll know. We'll be able to determine that. So this is one of those things where I don't. I actually genuinely don't know. I could sit here and like brain it out, but it's a waste of time because like if I ask for the third nth prime and I get the fourth, or if I ask for the third twin prime and I get the fourth twin prime, I'll be able to see by printing out twin prime list, right? Which we'll do. Cool. So let's actually just do that now. Oh. And then I guess, yeah, and then I can just return, that makes it easy. So then I can return twin prime list sub -1, because that'll be the last twin prime. Okay, boom. Okay, we're getting all kinds of things done. All right, now we actually have to solve the problem. So let's see. Well, len twin prime list is less than or equal to nth. So I need a system for determining if something is a twin prime. I could maybe write another function and it says like takes in a number, but I think that might be a little overkill. So I just need to start with something. Why don't I start with a primes list? Primes list equals a list, and I'm going to start it off with 2 and 3. So that'll be my first twin prime, actually. and we'll say our first twin prime here is going to be 2, 3. Okay. No. Nah, we won't do that. Okay, so prime list is 2 and 3. So what I want to see is, oops. So we need a divisor, so we'll say divisor equals, we'll start that at 3, and we'll start primes list at 2. And we'll say if is prime divisor. So I don't need to write is prime again, right? So I can just say if divisor is prime, if is prime divisor, right? Since is prime gives me true or false in return, I can determine whether divisor is prime this way, and I can say primes list dot append divisor. Now, okay, so now that I know divisor is a prime number, I can say I can compare it to the previous prime number. Okay. Yeah. Why don't I compare it first and then append it? So I'll say if divisor, which we know at this point is prime inside of this block, if divisor is, it'll be if divisor minus primes list sub -1, right? This is going to be the last element in primes list. So this is essentially like saying if my current number that I know is a prime number is, if that minus the previous known prime number is less than or equal to 2, then we can consider it an is twin prime. So what we can do is we can say twin prime list dot append, and I'm going to do this. I'm going to do a tuple, so we'll do parentheses. I need to do the previous prime, which is prime list sub -1, and the current prime, which is divisor. Okay, so then I add divisor. After that is checked and done, then I can add divisor safely in to that. So let's see what we get. I have no idea if this is going to work. Of course it's not going to work because I didn't call my function. That's reason number 1 why it's not going to work. Print. So what do I want to do? Let's see. Let's get the 3rd and the 4th and the 6th. Okay, we'll get the 5th too. For the 3rd, the 4th, the 5th, and the 6th twin primes. Cool. I think we had an example in there too. Yeah, okay, so the 5th should be 29 and 31. Ah, so something is broken. Yes, indeed. Oh, right. Of course. So I see what's broken. See if you can think through this. Let's see. It's so obvious now. That's why I always do this up front. Divisor divisor plus equals 1. I forgot to increment divisor. So since I'm adding 1 to it and I still want to check 3, I'm going to start divisor as 2. And then we'll go from there. Cool. What should this one? 5. The 5th twin prime should be 2931. And let's just put that next to this so we remember 2931. And that's what we get. Cool. So my check was correct to be inclusive of inf there. So I should probably do the first and second. Let's just be thorough about this. So first, second, third, fourth, fifth, and sixth, and seventh. We'll do that. Okay. Seventh. I'm just going to comment out this print of the twin primes list, and we'll go from there. So 3, 5. Oh, right. I actually do want that now. Oh, interesting. So I guess maybe it's not considering 2 and 3 to be a twin prime. Maybe that's what's happening. I do appear to have the right answer. But I'm just wondering, because I would think 2 and 3 would be considered a twin prime, but evidently not. But we'll see. You know what? This will definitely tell us whether or not we have the right answer. When we learn, will tell us if we did the right thing or not. Let's see. No, didn't do the right thing. Okay, so it expected 3, 5. Oh, no, it found 3, 5, and it expected 3, 5. So it really is expecting, see, this can be a frustrating error, right? But notice the parentheses instead of the square brackets. 2 and 3 aren't 2 apart. Yeah, but I would consider I would think since they're 1 apart, that would be considered a twin prime also, since it's even more, kind of like the ultimate twin prime, but I guess not, so. I mean, what do I know? I'm but a humble Python teacher, so. So it really is expecting a list in this case, so I'm just going to make this change here. It does want this to be a list. We'll make those square brackets there. I'll make them square brackets here. No, don't do it. Okay, there we go. So it looks like I got the right answer, but just the wrong type. Cool. Okay. So I think there's some room for optimization in my solution, right? Like, I just don't need that first thing to be in there, but I kind of, the way I have this written, I'm relying on it as a seed, kind of, which is, it's just not necessary. So I guess, you know what, I could do this. I could do 3. I could start it at 3, and the first number we could check, we'll start divisor at 4, and that will give us 5, 3 as our first twin prime. Let's see if that actually gives us the right thing. I think we're going to need to adjust this here. So 5, 7. Let's try this. Okay. So that, I think that cleans it up a little bit. Yeah, it looks like I don't have that initial pad in there that wasn't necessary. So that's a slightly optimized solution. So I will product improved version. Come on. Cool. And then I'm just going to get rid of that. It's no longer necessary. Cinch that up a little bit, and we'll run it again. Make sure I didn't break it. Cool. Nice. This is a fun one. I actually had to think for that one. I like a good Python problem. All right, cool. Got a little bit of a late start, so I'm going to keep going. We got this one. Where is it? Okay. Basic string operators and methods. It looks like the request is for problem 3. Let's see if we should go through this at all. Arithmetic operations, just want to understand string concatenation. Okay. Number 3. Okay, write a function called repchars. Takes a string as an input and returns a list of strings as output. Okay, so which takes a string as input, returns a list of strings as output. Okay. So let's just knock that out real quick, those things. So I saw the function name, print, repchars, takes in a string. Oh, here, this is great. This is what I want. This is exactly what I want. Trying to make some calls to the function. We'll just comment those out. And we'll say, do this. Print, okay. Well, def repchars takes in a string, so I'll call this string. Returns what? A list of strings. Stir list. How about a list? Okay, good. Let's run it, and I should just get 2 empty lists returned. Unexpected indent. Interesting. Very interesting. Differ by 2. Aha. Here we go. That docstring messing things up. Good. 2 empty lists. Each string in the output should contain a unique non-white space character from the string, repeated the number of times it appears in the string. Okay. So I think we can just do, I'm just going to go for C for character, in string, what am I doing? String, if string dot, what am I doing? String dot count, putting parentheses after stuff today that doesn't need it. If string dot count C, if the count, so if C, if the count of C in the string is greater than 1, stir list dot append we'll do string, no, we'll do C, which is our character, times string count C, which is the amount of times it appears in the string. I think that's it. I, bang, bang, bang. Ah, not quite. Not today. Okay. 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 So we'll do this. We'll say checked chars equals an empty string. Actually, we'll just make it an empty list. And then, actually, we'll just make it an empty string. And then we'll do, at the end, we'll say, we'll say checked chars plus equals C. And first thing we'll say is, if C not in checked chars and string count of C is greater than 1, then we'll append it. So let's see if that did it. We're still going to get white spaces, but I got to focus on one thing at a time here. Okay. Interesting. That's really interesting. String dot lower. Let's do that. So if I look at this, I know that my expected output is I. There's 2 lowercase i's. I see an uppercase I, and then I don't see another lowercase I. I just see 1 lowercase I. So I imagine it's got to be this uppercase I. So we'll try this again. We'll see if that happens. And we're still going to have white space in there, and we know we don't want that, but we'll get that out of there in a second. That did not fix it. Did I even do anything? Did I just notice a problem and then, okay, no, I did it. So let's see here. For C in string.lower. String.lower is going to be all lowercase version of string. If C, let me print C. Okay, so let's see if we get that lowercase I. I am. Bang, bang, bang. We got I am a string. Interesting, very interesting. Okay. So C. So if C is not in checked chars, I feel like something funky happened. Wow, we're really not getting those I's. And I wonder why that could be. Do we have a ASCII thing going on? Huh. Okay. Print C. Let's print C. Let's see if I ever activates this. Interesting. Let's take out checked chars again. just gonna do this. I never activates that. That's extremely weird to me. There must be something like really obvious that I'm missing, but I'm genuinely rather confuzzled. Okay, let's try something else. String equals string dot lower. We'll just do that. I'm not sure that's gonna have anything to do with it. I'm probably just missing something. Oops, missing something like really obvious. That works. For some reason that works, but not the other thing. Oh, I understand. Because I was getting the count of C on string, which was not dot lowered. So this way I made string dot lower everywhere, not just here. I made it dot lower here and here as well. And that's just, I should have caught that right away. That's just me being silly. So that works. We also want to say if C is not a white space character. So in checked chars, I'm actually just going to put a space in here, and that means if C is not in checked chars, if C is a white space character, it's going to already be in checked chars, and we can just do that there. I could make another explicit check and say like if C not equal to like to that, but I can literally just throw it in check chars here. And this says, let's see, non-white space characters. So this is not just space, this is also going to be \n as well as \t, which are the other white space characters. So there we go. \n space black. \t. God. Excuse me. Okay. So let's see if that works. That should include no white space characters. Okay, cool. So we got I, bang, bang, bang. And that's what we're expecting. And then an empty list. Perfect. I've got this print C here. I can get rid of that. And I want to just make sure I get all my debugging and printing stuff out of the way. So we're ready for final code. Bingo. Cool. Let me know, to the question asker, let me know if this is helpful. If this is answering your question, or if you have more questions, or if you're thinking about quitting Python forever because I gave such a bad explanation or something, whatever. Okay. Cool. So here's my solution. Let's see what we have here. Here's an example solution. So they did the same thing. Lower string equals string dot lower. Initialize collectors, letters seen. I'm doing check chars, and I'm doing it as a string instead. And result, which I'm calling stir list. But these are basically the same as these collectors. For char in lower string, char count equals lower string dot count char. Then we say if char count is greater than 1 and not char count dot is space, I'm handling that by just throwing that in my collector and making sure C is not already a member of that collector, which will move those around or something, which will, it'll check it'll check those white space characters. Okay, sometimes I hear the words that come out of my mouth. it's also checking char not in letters seen, right? So it's doing it, I think, in basically the opposite order that I'm doing it. But it's the same checks. It's still checking for the same things. Then we're going to result.append char times char count, and then append the char to letter seen. Oh. I guess we could make that append there. Yeah, why not? Why not? We could add it in right here. Is that really going to work? Guess that works. Okay. Cool. I do kind of like the idea of making this, renaming this like lower str. And then also doing like char count, C count equals lower str count C, and we'll just replace that with C count. And then that way we only have to perform this operation once, and it's just a minor savings, you know, so we can do that count once and then just save it rather than running that count operation twice. It's a very minor sort of optimization, but I'm kind of in OCD coding mode right now, which is nice or something. I don't know. Let's see if that's going to break everything. No, it works. Cool. Okay. An alternate solution using set. Oh yeah, okay, so that's an interesting one. So here we make a set, and we don't, what does that save us? That saves us the need to do this checked chars thing. Although in my solution it's kind of nice because I'm using that also for new lines and tabs and spaces as well. So that works out. Cool. Good. All right, that's the last question that I see. And to the person, I know somebody asked a question that we didn't get to. I will DM you after stream. If you're still on, just stand by. I'll connect with you in a minute here. I am going to get ready to teach Premium Prep in about an hour, so if you're in that, I will see you then. So yeah, do let me know if there were, it seems like the stream quality was good based on how people were responding in Slack. Do let me know if it could be improved, or just in general, feedback is always appreciated. Let me know if you liked the material, or if you have other requests, or yeah, just whatever. Feel free to DM me on Slack. Cool. Yep, so I'll be streaming again on Wednesday, and look forward to it. I'll see you all then. Bye-bye. Have a good rest of your day.